Hello and good evening to all of you. Today we will be discussing about the structure of the sun. So there are some basic informations which we need to understand before jumping into the technicality of the structure of the head of the solar system. Sun is 4.5 billion years old structure. 4.5 billion years old. Sun represents 99.99% mass of the total solar system. And the diameter of the sun is 109 times the diameter of the earth. The diameter of the sun is 6,96,000 kilometer. 6,96,000 kilometer. It is the diameter or it is the radius? No. It is the diameter or it is the radius? I don't think so. It is the diameter. It is the radius of the sun. So you can understand, if this is the radius of the sun, then how it is 10 times the radius of the not the diameter of the earth. So these are some basic things. Apart from this, could you tell me which is the constituent which is found maximum in the sun? Maximum. That is the hydrogen. Hydrogen is present 70.4% hydrogen. And helium, how much helium is present?
29.
It is 27.6. So when you add, it will come 98%. And in remaining 2%, the elements like uranium and these are present. So maximum proportion goes to the hydrogen. The process which takes place through which the sun generates the energy, that process is called nuclear fusion. There are two processes. The one is nuclear fission and the other one is nuclear fusion. In nuclear fission, what happens that the one molecule divides in two parts. And just opposite to the nuclear fission, the reaction that is called nuclear fusion, in this reaction, the atom gets combined. In nuclear fission, the atoms are divided, and on this nuclear fission reaction, the bomb which was thrown by USA in Japan, or the Pokhran experiment which happened in 1974, after that the 1998, These are based upon the nuclear fission, where the dividation happens. And just opposite to this nuclear fission on which the sun is based, here the two atoms of the hydrogen are combined and the formation of helium is happening. This process was started 4.5 billion years back, and it is still happening, because the day it will stop, the sun will be dead. So when the two atoms of the hydrogen are combining, we call the nuclear fission, and the formation of helium happens, and this has been happening for last 4.5 billion years ago, and this is the process through which the sun generates the energy. The complicated thing is related to the sun, that is the structure of the sun. There are the layers. When we go through the structure of the earth, then we come across with the layers like troposphere, stratosphere, mesosphere, thermosphere, and the last one is the exosphere, which finally gets mixes with the space. In the same way, there are 6 layers of the sun. 6 layers. And the very first layer, that is the core part of the sun, that is called the core itself. It is called the core. The temperature of the core is 15 million degree centigrade. 15 million. It is not 15 million degree centigrade. So you can understand what is the temperatures here. In 100 degrees Celsius, the water starts boiling, and this is 15 million centigrade. The conversion of this reaction, the nuclear fusion, it takes place in the core area of the sun, where the formation of helium from hydrogen happens. And as you go forward from the core, you will come across with a second layer, and that is called which one? That is called radiative zone. The formation of energy which is happening in the core through the nuclear fission, this energy reaches to the radiative zone through the process called radiation. And in this radiation zone, the formation of X-rays, gamma rays, and photons. Photons are the light carrying particles, are formed in the second zone, or in the second layer of the sun, that is the radiative zone. After the radiative zone, the third layer is known as what? Third layer. Convective. It is called convective zone. This is the convective zone. And in this convective zone, the hydrogen cells are present. Hydrogen cells are present. So hydrogen cells means, like this. These kinds of hydrogen cells are present, and the formation of energy which is happening in the core which starts going towards this direction, could you guess how much time is taken in order to reach the energy which is being formed here to the conductive zone or above this? 1 year, 2 year, 5 year, or 10 year? The energy which is being formed here, 11 hours. 1 million year is required. 1 million year is required, the energy which is formed in the core and going or reaching to the conductive zone and beyond that. The energy, as I have told you, means the hydrogen cells are there in this zone, the hydrogen cells are there. The energy is going through with these hydrogen cells, because these hydrogen cells are present everywhere in the third zone or the third layer of the sun, that is the convective zone. And after the convective zone, the fourth layer is photosphere. Photosphere. This is photosphere. And this layer is visible to the people who are living on the earth. Or you can say, we can see this layer, photosphere, from the earth. It is visible from the earth. It is like a red rose, thin layer, which you can see from the earth. Photosphere is also famous for one thing, and that is called the sunspots. Sunspots. So what are these sunspots? These sunspots, actually what happens in the photosphere, the energy, okay, the radiation happens. So what happens that you can say the flame, the fire flame, it goes like this, and the fire flame at the temperature of the fire flame is around 6000 degrees Celsius in the photosphere, 6000. But what happens, this fire flame, it keeps on going forward, and a time comes when the temperature of that solar flame decreases to the 4000 degrees Celsius, 4000. And when it reaches to the 4000, it again comes back to the photosphere. It again comes back to the photosphere. And when they come back, because the temperature is reduced, what happens that they create a place. I mean, you can understand that, this is the solar flame which is going upward, and as the temperature is decreasing, it will come backward. So so many flames will be coming back, and what will happen that the solar flames which are coming back, if they are meeting in this particular point, okay, if they are meeting in this particular point, this point will be known as the solar spot, and the temperature of these solar spots, sometimes it goes to 1500 degrees Celsius. When you compare the temperature from 15 million or from the 6000, this 1500 degrees Celsius temperature, it will be very cooler, because our reference point is very high. And because of this temperature, we also call them the cooler places or the cool places. However, they are not cool. If you compare this thing from the earth, then even this much temperature is very high. But when your reference point is 6,000 or this 15 million, then certainly this temperature, which is 1500 degrees Celsius, is nothing. And because of this thing, we call them the cool points. And these cool points are formed. These sun spots are formed if you take this is the sun, okay, and this is the diameter of the sun, the radius of the sun, this is the radius, 6,96,000. So this is the diameter. The formation of the solar spots happens here and here, and it can goes to the 40-degree latitude. So it can, this is the 40 degree, and here also 40 degree, the same thing. So maximum it can go to the 40 degree here and anywhere in between. When the sun spot is formed on this particular point, when the sun spot is formed on the equator, at that time our earth experiences the maximum radiation, maximum insolation, and this maximum insolation affects the atmosphere and affects our monsoon season as well. I will discuss this thing in my next lecture, but it affects our monsoon as well when the solar spot is formed on this portion, on the equator of the sun. Beyond 40 degree, you cannot find the solar spots. Exceptions are always there, but exceptions can never be the examples. So when the solar spot is formed here, we call it solar maxima. And when the sun spots are formed here, we call it solar minima. Solar maxima and solar minima. In order to reach from this point to that point, we need 5.5 years. And from here to here, 5.5 years. I mean, this is the sun. It is looking little small, but you have to understand it is the sun. So 5.5. We can say, or we can conclude that after every 11 years, we experience one solar maxima and one solar minima. After every 11 years, when you add this 5.5 and this 5.5. So when the solar minima, when the sun spot is there, that time the earth experiences comparatively lesser amount of insolation as compared to the solar maxima, when we are experiencing the maximum one. So we need to keep in mind that the formation of solar spots happens where? On the photosphere, that is the fourth layer of the sun. And after the photosphere, the next is the, I think, after all, it's the sun, so everything will be less for designing it. And this layer is called the chromosphere. Look, chromosphere can be seen during the eclipses, especially when the solar eclipse takes place. When the moon covers the sun, we see a red ring, and that is called the chromosphere. So chromosphere can also be seen from the earth, but during the eclipses. And the last layer of the sun is which one? Yes, corona. When COVID-19 happened, that time I heard this word for the very first time. I think that time I was not going through properly with geography. Otherwise, I would have certainly heard that word. Because the word corona was completely new for majority of the people. Because they hadn't gone through with the geography or with the structure of the, if there was any serious UPSC experience, certainly for him the word corona was not shocking. So the last layer is the corona. Generally, as you go far away from the sun, it is very natural that the temperature will keep on decreasing. Applying this logic or this analogy, could you tell me, if we compare the three layers, the photosphere, the chromosphere, and the last one is the corona, which layer would be having the minimum temperature? Or tell me the maximum one.
Corona maximum.
Why corona maximum? Despite of the fact corona is farthest away layer of the sun. You are right. Corona, the temperature of corona is in millions. Minimum 1 million degrees Celsius. Despite of the fact that corona is the farthest layer from the core of the sun. So this thing is quite ironical in nature, but this is the reality. Okay, so I am not saying that corona would be having the maximum temperature in comparison to all these layers, but certainly the corona has the more temperature than the photosphere and the chromosphere. So these are the important layers of the sun, which design the structure of the sun. The last thing, that is, earth revolves around the sun, moon revolves around the earth, and every body revolves around somebody. In the same way, the sun revolves around what? The sun revolves around what? Or the sun is stationary in nature. Sun does not revolve.
Galaxy.
Yes. The sun revolves around the center of the galaxy. Around the center of the galaxy, that is also called the black hole or the bulge. And in order to complete one revolution of the center of the galaxy, or galaxy is Milky Way, how much time is required? In how much time, in how many years the sun completes one revolution of the center of the Milky Way?
25 वर्ष.
No, it is not 25 years. It is 25 crore year. 25 crore year. So the earth completes one rotation, one revolution in a year, in 365 days. If you don't go in the technicality of 1 by 4. And we call it 1 year because the one revolution is completed here. Let's assume if anybody has the life of 10 years according to the structure of the sun, then you can calculate 25, because 1 year of the sun will be accepted when the one revolution of the sun is getting completed, and the one revolution takes 25 crore years. So if anyone has 2 years life on the sun, then you can he will be alive for the 50 crore years. There is a story when a boy, that was the last day of his life. So every god started thinking, because he was going and touching the feet of every god, and everyone was saying, okay, Ayushman Bhava. And later on it was being told to the god that, oh, you have told that Ayushman Bhava, but this is the last day of the life of this boy. What will be the significance of your boon if you are saying you are a god and there is no any significance of your saying that Ayushman Bhava? So somebody told in a very secret manner that you go to the Lord Shiva. Okay, if he says, so according to the Shiva, I mean, if he is saying that you will be alive for 1 day or one more, so according to that parameter, that time period was very, very high. I exactly don't know, but this story I heard in my childhood. So he was told that Lord Shiva told that you will be alive for this particular day. So when it was compared, okay, the way we are comparing 1 year of the this earth and 1 year with respect to the revolution of the sun, these are very different. So in the same way, the Shiva gave the boon, and so you can understand the boy who was about to die, by that night he became immortal. So and this 25 crore, the one revolution in which the sun completes one, this 25 crore is also known as the galactic year, one galactic year, or the cosmic year, one cosmic year. One cosmic year is equal to 25 crore years, or this one revolution of the sun. So these were some basic informations related to the sun. The technical thing is the structure of the sun, the layers, which I think we need to give in mind. If we don't know their characteristics, at least we need to know the sequence of these layers, because in most of the cases in state commissions, instead of asking the description, they ask which one is the layer where the black spot is formed, or what is the sequence of this layer. Okay, because it is little difficult in comparison to the structure of the earth, where the troposphere, stratosphere, mesosphere, thermosphere and exospheres are. So this was as far as the structure of the sun was concerned. In my next lecture, I will be discussing some other things. Namaskar.